Learning objectives. In this chapter, the user would learn the following in detail: object-oriented relationships, relationship integrity, ER diagramming models for object-oriented relationships, different notations, GOAD, UDON notation, SLAR, MELOR notation, OMD notation, UML notation, and Booch notation. Integrating objects into a relational database. Integrating objects into a relational database. In object-oriented data model, a class is an entity, the element that is involved in data relationships. When we look at merging objects into the relational data model, a class takes on an entirely different role. It becomes a domain, acting as the data type for a column. There are two very important implications of using a class as a domain. It becomes possible to store multiple values in the same column in the same row because an object usually contains multiple values. However, if a class is a domain assigned to a column, then any given intersection of a column and row can contain only one object created from that class. The relations therefore still conforms to the relational constraint of there being no multi-valued attributes. It becomes possible to store procedures in a relation because an object is linked to the program code for the processes that it knows how to do. Integrating objects into a relational database. Limitations of object-oriented structures in relational database. Current implementations do not support inheritance, therefore it is unable to relate classes in that way. However, because a class is essentially a user-defined data type, you can use composition to build complex classes from simpler classes. Although a database management system vendor and third parties may not recognize columns with classes as domains, this means that application development must be done in a high-level language such as C++ or COBOL to take advantage of the objects until such time as the tools catch up with the database management system. Some database designers have attempted to make a relational database act like an object-oriented database by creating a class that corresponds to an entity and then creating a table with one column for the object and one or more columns for the primary key. Problem with this approach is that a relational database doesn't represent relationships like an object-oriented database, which uses pointers much like a simple network database. Columns are needed for foreign keys. The result is a design that is clumsy and hard to maintain. This is therefore not a recommended approach for relationship database design. If you need an object-oriented database, then that's what you should be using rather than trying to force a relational database to behave like one. Object-oriented relationships. Relationships. They represent logical links between two or more entities or objects. Residence is an example of a relationship that can exist between the entities city and employee. Exam is an example of a relationship that can exist between the entities student and course. An instance of a relationship is an n-tuple made up of instances of entities, one for each of the entities involved. The pair of objects made up of the employee named Johansen and the city Stockholm, or the pair of objects made from the employee Peterson and the city Oslo, are examples of instances in the relationship residence. Examples of relationships. Types of relationships. Relationships between classes are defined as below to know how objects relate to each other. Following sorts of relationships exist: aggregation, inheritance, using association, instantiation, aggregation aka composition. Different authors use different terms for the idea of containment. UML has a very specific use and different symbols of the terms aggregation and composition, though this is not necessarily consistent with OO authors. UML aggregation is weak containment, usually implemented with pointers, and the symbol is an open diamond. Composition is strong containment, implemented by value, and the symbol is a filled diamond. Composition: every airplane has an engine. Aggregation: airplane may have passengers, they come and go. An aggregate object is one which contains other objects. For example, an airplane class would contain engine, wing, tail, crew objects. Sometimes the class aggregation corresponds to physical containment in the model like the airplane, but sometimes it is more abstract. Example, club and members. The test for aggregation is to see if there is a whole part relationship between two classes as a synonym for this part of. Inheritance terminology. When we use inheritance, we have classes at the top of the hierarchy that are known variously as generalization, parent, superclass, base, abstract. And classes at the bottom of the hierarchy are those which inherit from some other class known variously as specialization, child, subclass, derived, concrete, inheritance. The class toward the top of an inheritance hierarchy tend to an abstract classes that won't have any objects instantiated from them. The bottommost classes of the hierarchy are the concrete classes from which we actually make objects that do work for us. Inheritance, generalizations and specializations. Generalizations represent logical link between an entity E known as parent entity and one or more entities E1, etc. En called child entities, of which E is more general in the sense that they are a particular case. In this situation, we say that E is a generalization of E1, etc. En and that entities E1, etc. En are specializations of E. Generalization types. A generalization is a total if every instance of the parent entity is also an instance of one of its children, otherwise it is partial. A generalization is exclusive if every instance of the parent entity is at most an instance of one of the children, otherwise it is overlapping. The generalization person of man and women is total. The sets of men and the women constitute all the people, and exclusive. A person is either a man or a woman. The generalization vehicle of automobile and bicycle is partial and exclusive because there are other types of vehicle, for example, motorbike, that are neither cars nor bicycle. The generalization person of student and employee is partial and overlapping because there are students who are also employed. Inheritance advantages. Avoid redundant code by sharing it between classes. Inheritance relationships let us avoid the redundancy of declaring the same instance variables and behavior in a group of later classes. For instance, dogs and cats do not both need a name variable, they can inherit it from pet. Enforcing standards at a design level. Interfaces. Programming by drag and drop components. Avoid redundant code by sharing it between projects. Reuse. Shared code allows for rapid prototyping via reuse. Shared code produces greater reliability via greater use and hence discovery of errors. Inheritance disadvantages. Increased class abstraction coupling. Program size. Using large class hierarchies makes your project bigger. Dealing with the runtime dispatch of messages to objects related in an inheritance hierarchy as memory overhead. Understanding a large system, the yo-yo problem, class documentation. Inheritance means that it is not sufficient to study the header file declaration of a class to completely understand its behavior. You often must look up the hierarchy and consider the inherited behavior and state from its superclasses. On a particular note, this can be a pain for documentation since you may not find the behavior you seek in the document for the class itself. Inheritance UML notation. Every sab is a car. S realizes G. Class S implements interface G. D is dependent on I. Changes to I may affect D. Inheritance generalization. Using. When a class definition uses another class as a parameter to a method or declares an object of that class local to one of the member functions, then we say the first class is using the second. Using is not the same as aggregation, since the class being used doesn't satisfy the whole part question. The used class exists to help the first class. Example, a class for calculating voltages, currents and power in an electrical circuit would need to deal with complex numbers a lot. A complex number class would be used to pass arguments to methods, hold temporary values, etc. Association. Classes that cooperate with each other or are associated with each other through the model of our problem need each other's names to message back and forth. This is usually implemented in C++ by putting pointers to objects in class definitions, just like graph had a pointer to nodal list. Association implies symmetry. Both classes know each other and can message each other. A product class object may need to know the last sale that it was involved with. We could put a pointer to sale class object inside the private section of product. A sale class object may need to know all of the products involved with the sale. We can put a pointer to a pointer, double pointer in sale that will let us store 0 or more products associated with the sale. Associations have a cardinality. They can be one-to-one, one-to-many or many-to-many. Example, each product is part of one sale. Each sale has many products. Associations are the most generic of the relationships between classes. A class may also represent an association between two other classes. For example, a skill and a person are associated with one another. A person can have some number of skills, and a given skill may be associated with some set of persons. To define the relationship, a person skill class can have state such as proficiency and years experience, which tell how good a particular person is at a given skill and how many years experience they have with it. Instantiation. The potential confusion for people new to OO is that instantiation is what happens to create an object, yet this is a class to class relationship. No objects are involved. Another term for this relationship is generics. A generic class arises from a situation where the behavior of a class can be abstracted into something which is relevant to more than one type of state. The goal is to share the definition in the class of some behavior, that is, the methods, across different data types. For example, a stack class has the same fundamental behavior whether it is holding dogs, integers, strings, etc. We shouldn't have to define a dog stack, int stack, etc. as separate classes with nearly identical methods. Instantiation UML notation. An instantiation relationship is displayed in the diagram editor as a dashed line with an open arrow that points from the classifier that performs the operation to the classifier that is being instantiated. The keyword instantiate is attached to the connector. In an instantiation relationship, the client model element is instantiated by the supplier element and is therefore dependent on it. Relationship integrity. Referential integrity. Many relational database management systems include mechanisms that enforce a database's referential integrity. Referential integrity is another measure of the consistency of the data in a database. Referential integrity is violated when the relation to which a foreign key refers no longer exists. For example, if one deletes a donor from the donor table without also deleting the corresponding donations from the donation table, then the donor ID field in the donation record would refer to a non-existent donor. Entity relationship diagrams. With databases, as with programming, manufacturing, and many other disciplines, before we build, we should design. The database's design process begins with the design process of the application as a whole, including consideration of users' requirements, design patterns, and system requirements. An entity relationship diagram is used to illustrate all of the entities that an application must handle and the relationships among the entities. This information is the blueprint for building the database tables. Entities typically correspond to nouns that are involved with the process being automated. In an entity relationship diagram, entities are shown with their attributes listed below them. Entity relationship diagrams. There is no one standard way to represent relationships. Some designers use diamond shapes containing a description of the relationship. Others use lines to connect the entities in a relationship. The line should specifically link each foreign key to its designated primary key as shown in the diagram below. Types of relationships. Both of the relationships illustrated, opposite or one-to-one many relationships. Each record in the donor table may correspond to many records in the donation table. However, each record in the donation table has only one corresponding record in the donor table. Similarly, each project may have multiple donations, but each donation is made to only one project. In entity relationship diagrams, the one side of the relationship is usually represented with a numeral 1 and the many side of the relationship with either an M or the infinity symbol. Types of relationships 1-to-1. Sometimes relationships are 1-to-1. Suppose that each of the manufacturer's products comes with one and only one user manual, and each manual only describes the product it accompanies. 1-to-1 relationships are somewhat rare, since one of the entities can often be represented simply as attributes of the other. Some database designers may choose to collapse the schema above into one entity. Such a design decision would depend on several factors, such as the performance or significance of the individual entities within the application. For example, if other entities, like an author table, in the schema also have relationships with the manual, then it is probably best to keep the manual entity separate from the product entity. Types of relationships many to many. Many to many relationships are usually represented with the use of mediating one to many tables. Returning to our charity example, we can see that there is essentially a many to many relationship between donors and projects. Each donor may contribute to many projects, and each project may benefit from multiple donors. If we were to try to include the project IDs in the donor table and the donor IDs in the project table, we would end up with a denormalized mess on our hands. The introduction of the donation table deconstructs the many to many relationship into two very manageable one to many relationships. Types of relationships. Recursive relationship. A recursive relationship occurs when a column in a table refers to the primary key in the same table. This is very useful when describing hierarchical data structures in a table. In the following table of categories, for an encyclopedia website, the parent ID field refers to the category ID field. The history category parents the Asian history category, which in turn parents the ancient India category, and so on. Each record has a relationship with at least one other record in the same table. The following entity relationship diagram demonstrates the relationship. Conclusion. In this chapter, we have covered the following in detail. Object-oriented relationships, relationship integrity, ER diagramming models for object-oriented relationships. Different notations: GOAD, UDON notation, SLAR, MELOR notation, OMD notation, UML notation, and Booch notation. Integrating objects into a relational database.